In this video, we're going to parameterize the triangle with vertices A, B, and C using the following setup. We're going to have this triangle, and then how I'm going to parameterize it is I'm going to have one vector, which I'll color in red, that goes some way along the direction of the vector AB. And then we'll have another vector in, let's say, blue that goes some way along BC. And my goal will be to kind of figure out what to call these vectors in order to describe this parameterization. First, let's go ahead and just give some of these vectors some better names. So we'll call the vector from AB. Normally we'll write that as AB, but just for simplicity, we'll call it U. We'll call the vector from A to C, normally that's AC. We'll call it V. And then we'll call BC. We could just call it BC, or we could give it a new name, but what I'm specifically going to call it is I'm going to call it V minus U. You could really call these whatever you want, but that's how I'm going to define them here. So this vector that goes a little way along A, or along the vector U, we're going to think of that as the vector AB times some scalar multiple. So we'll call it T times the vector U, where T is between 0 and 1. So that takes care of this first vector. The harder problem is, what am I going to call this B vector? Or sorry, not this B vector. What am I going to call this blue vector? Well, we're going to start by drawing a little similar triangle here. If I draw this similar triangle, then what I see is that this smaller triangle is just this bigger triangle scaled by t. So this whole vector here, I could call that whole vector t times v minus u. Because I took the vector v minus u, which is this big long one here, and then I scaled it by t. So what I really want to do is figure out what am I going to name this vector that's going partway along the vector t times v minus u. Well, one thing we could call it, there's kind of two different ways to handle this. I could call this, depending on your preference, we could call it, I like calling it st times v minus u, where s is between 0 and 1. That does the job, because s represents kind of what fraction along this t times v minus u vector I'm going on, just like this t over here represented what fraction I am going along this AB vector. Another way you could do this is you could just call it s times v minus u, but where you're going to have to pay for that complexity a little bit is now s isn't bounded above by 1, it's going to be bounded above by t. So we're saying we can go any fraction of this whole vector bc, or v minus u, as long as it's at most t. So we're saying I can take any fraction that's between 0 and t and take that much of this vector. So we'll go ahead and use the first one, but either one works. So we'll call it st times v minus u. It's also worth noting this first option, you're going to be parameterizing this triangle with a square, which is a little weird, but it totally works. This option, you'll be parameterizing a triangle with another triangle, which might make more sense to your brain, maybe. Okay. So now I have these vectors, and now we want to know how I'm going to parameterize. So I will tell you something. This is actually my second time making this video because the first time I missed an important part. Because essentially how I want to get to this point is I want to follow tu, and then I want to follow st times v minus u. But it's really important where I start. I'm starting at this point a. So essentially what I'm going to have is I'm going to have a plus, I'm going to take a, I'm going to follow the vector u for about a fraction of t. And then I'm going to take the vector v minus u, and I'm going to follow that for a fraction s times t. And that would be a parameterization. So let's go ahead and just throw some random numbers up here just to see what this parameterization would look like in practice. Let's say my points are something like 0, 3, 4, 0. We don't need another 0 there. We'll make it 1, 2, 3 just for fun. And as long as I don't make these parallel, or collinear, we should be fine. And I doubt I'll do that. How about 4, 3, 2? So we're going to have, we'll call this one A, we'll call this one B, we'll call this one C. What would this parameterization look like? Well, let's go ahead and get my vectors. U is going to be the vector AB, the displacement vector. So that's going to be 1, negative 1, negative 1. V is going to be C minus A. So that's going to be the vector AC. That's going to be 4, 0, negative 2. And then last but not least, V minus U, we could also have written as BC. And either way you do that, you should end up with 3, 1, negative 2 minus negative 1 is one way to think about that. 3, 1, negative 1. Let's see if that works this way. 3, 1, negative 1. Worked both ways. So my parameterization would end up being A, which was 0, 3, 4, plus t times, I mean, you could have changed the roles of s and t here. This is just kind of how my brain thinks about it. We'll have t times the vector AB, so that's 1, negative 1, negative 1. And then we'll have st times v minus u, which is this 3, 1, negative 1. And when we do that, we're going to get, what do we get here? We can combine that all into one vector. That would give me t plus 3st. Then we'd have 3 minus t plus st. And then we'd have 4 minus t minus st. And that would be my parameterization. If you wanted to do it using a triangle, basically all of these STs would turn into S's instead. Keeping in mind that now you're kind of parameterizing over a triangular region instead of a rectangular region. And one of those might be easier than the other. So there we go. We set up a parameterization for a triangle with given vertices here.